Okay, guys, this is part two. I don't know because the algorithm isn't really putting the first video out, but that's okay. I also think like this for me, it's a really helpful like study tool because I'm just like explaining things, so it actually makes me like think about like everything, and it's like, oh wait, I don't actually know this. Hold up, let me look at it. Anyway, back to part two, locking in the internet. So, something that's really important to focus on that I think you should definitely study on is the digital divide. Also, this trips me up a lot, so if I get anything wrong, feel free to correct me. Okie dokie. Yes, the parts of the internet is all the protocols. Um, so I'm looking at my journal for CSP. So there's also like the difference between a computing system and a computing network is a computing system is multiple devices that work interconnectedly for a certain task, and a computing network is multiple computers or devices, just digital technology that is able to send information to each other. So that's that. Okie dokie. Okay. So IP addresses, it's a type of protocol. It's used to identify different devices, and it's used whenever one device communicates with another device. So each one is given an IP address when they're connected to a network, and yeah, they just communicate. Send data through packets. Um, there's TCP and UDP. TCP, it's more reliable. I wrote notes while I was studying because I'm like, I'm gonna refresh on this. So TCP is more reliable. It resends lost packets, and it also, like, if they become like out of order, like, I'm pretty sure it reorders them. Let me double check. Does TCP? Yes, it does. It does. Um, right. But it is slower than UDP, and that's the one pro to UDP is that it's faster. It a lot of like cons to it is that it doesn't resend lost packets. It doesn't reorder them if they come out of order, and it's way less reliable, but it's faster. Um Another thing that I see a lot, IPv4, so and IPv6. The one main thing about those two, which will appear on most of the questions that you see, or at least the ones I've seen in the practices so far, IPv6 is more scalable. Um, but yeah. Oh, okay. I did not really look at these much. There's HTTP and DNS, and quoting from Khan Academy, not my words, protocols powering the World Wide Web and what the browser uses every time you load a web page. Khan Academy's words, not mine. Okay, so let's see. Computer networks. Okay, I talked about computer networks. Oh, yeah. There is a local area network, and that's basically things that are like literally just, it's in the name, it's local. Okay. Um, Wide area network, I would say, okay, so think of local as like your state kind of thing. And think of wide area network as like the whole country. Wait, I'm gonna see if that's right. I haven't really seen any practice questions on this. Yeah, that works. Generally not across the whole date, but like think of it in like an area, like that community you live in, the county, that would work. But I was right about it being like something like the whole country for a wide area network. Um Protocols are basically the rules of how like a network or like transmitting data, like how anything really on like the internet kind of really works. Basically, it just sets rules and creates like consistency is the word I'm thinking of. If you know what I'm saying, y'all. Um because without the network protocols, it would be harder to communicate because not everything's running by the same rules. So basically think about like the rules in like your school or something. Like everybody has to follow the same rules, otherwise chaos, I guess. I guess, bro. Okay. There's a lot of stuff on physical network connections, non-physical. I haven't really seen anything about them on the practices. So if you want to look at it and study it, I'm not covering it though. Um Bit rate is basically the rate bits are sent over a bandwidth, I'm pretty sure. Wait, no. Oh yeah, the number of bits sent each second comes from Khan Academy direct quote. Yeah, so basically yeah. Bandwidth is the max amount of bits a system can use to send data back and forth. Yeah. Oh, latency. We did talk about this in my class, not much. Direct quote from Khan Academy, latency measures how late the bits arrive. So, that's what that is. Internet speed. I think we all know what that is. I would hope so. Cuz I'm assuming you're using some people, most people are using the internet to watch this, right? If the algorithm decides to work. Yeah, IP4 addresses, IP6. I covered those. Subnets, you don't need to know. At least I don't think you do. IP packets, I went through those. Oh, okay, so the different processes and steps basically outlined in Khan Academy, not my words. Step 1 is the packet is sent to the router. So basically, like the starting point has like, this is my own words. The starting point has like an end destination. That end destination is the IP address given, and the data is split into multiple packets to like send it across, also to like kind of improve the efficiency, and also fault tolerance, I'm pretty sure, because if one packet is going like, okay, let's say that's connected, and this is a destination, like 1, 2, 3, 4, right? And if this is broken off, this can't get there, it's lost. But this packet goes like this way, and it gets to the destination, and these get to the destination. And if it's using like TCP, this packet that was lost up here, these three are already sent. And then it realizes, oh, there was one packet that wasn't sent. We'll resend it, but it just makes it faster, more efficient, fault tolerant. Yeah. Second step, router receives packet, router forwards packet, final router forwards message. That's what it says in Khan Academy. Okay, redundancy is the multiple different ways, like the multiple different paths a packet can take to get to that IP address of the destination. So basically, what I just pantomimed. Fault tolerance, what I described. I'm not really going into depth with this unit, really, but you should definitely look at this unit if what I'm saying does not ring any bells. Because then I'd be a little worried for you. The World Wide Web. Okay, basically the main thing is the World Wide Web is in the internet. You know? Like, you need internet to use the World Wide Web, but you don't need the World Wide Web to use internet. Catch my drift? Basically, okay, quoting from Khan Academy, the domain name system gives us humans an easy way to identify where we want to go on the internet. Why did I click on the picture? A domain name is a human-friendly address for a website. Yeah. Okay, so that's Khan Academy's words, not mine. Okay, also Khan Academy's words, HTTP. Actually, I want a little bit more on that, so I'm not using Khan Academy for that. Okay, this comes from GPT. So basically, it's used when you type in a URL and press enter. It sends a HTTP request to a server, and then you get the web page that you're looking for. HTTP versus HTTPS. HTTPS is more secure and it's encrypted. HTTP does not. Yes, basically. You can hear me typing. Okay. So, on to the next part of 2. Scalable systems. Okay, that's basically like getting more people to be able to use a certain thing. So, like how I mentioned before, IPv4 versus IPv6, more people could use IPv6 and they had to like create it because they were like running out of, I think, IP addresses in IPv4. Double check me on that last part, but that definitely shows scalability. Another thing that shows scalability is like if there is an increase in user usage, like the ability for users to use it. For example, if you have it just to like Apple phones and then you scale it to be able to have Android users use it too, that shows scalability, I think. Okay, Internet Protocol Suite. Okay. Okay, this is actually helpful. This comes from Khan Academy, guys. So application layer, top layer, imagine that. HTTP, TLS, DNS. Transport layer, TCP, UDP. Network layer, IP. Like I said before, version 4, version 3, V4, V6, not 3. And link layer, Ethernet, and wireless LAN. So that's like a visualization if you guys want to visualize it. That's actually helpful. I like that. Internet Protocol Suite. We just looked at that. Open Protocol Development. Standardization is the word I should have used earlier. But yeah, I covered that basically. An open protocol is something that doesn't have like one set owner to it. Comes mainly from Khan Academy. I've just paraphrased it. Oh, the digital divide. So basically, the digital divide is an unequal access that people have to technology and like things that go with it. So like computers, phones, laptops, Wi-Fi, the unequal access people have to that's the digital divide. Some things that could cause it, or some categories, is the global digital divide, geographic, socioeconomic, and digital use. I think, okay, so digital use, I'm pretty sure, is basically when some people just do not know how to use it, I think. It's like when you think about people who are like maybe older or people who have never like seen tech before and they just don't have any learning on how to use it, and they don't have things like CSP classes. Socioeconomics, some people just, I hope that is what that is. Otherwise, I'm going to seem really dumb. Yeah, I think that's just people who have like different incomes and a different ability to afford things. Like some people might not be able to afford a laptop. Well, some people can. Geographic digital divide, think of it like if you're on top of a mountain, it's going to be pretty hard for you to get any access to like Wi-Fi or anything because all of that is on like ground level and you're like all the way up there on like Mount Everest or something. The global digital divide is, I think, the digital divide between different countries is how I would kind of explain it. For example, some countries or some like states, however, whatever you want to think about, they might have governments that like restrict that access, while other people in other countries have like a more lenient access, less restricted, that type of thing. So that's that. Definitely 100% look at the digital divide if you're going to look at anything. Digital divide algorithms, those I think, in my opinion, come up a lot. So I'll see you guys for the next part if this really helped, and I hope it did. Yeah. If you have anything you want to add, feel free, add it in the comments.